Today's lesson is going to be the last in our series on Learning Target 1, Solving Quadratics. This one's on the quadratic formula. We're going to talk about what is the quadratic formula and how it is used to find the solutions of a quadratic equation. This is the third way that we have to solve a quadratic. We have factoring, completing the square, and third way is quadratic formula. It's important that you do commit to memorizing this. So there's lots of ways to do this. I suggest maybe hitting up YouTube. There's tons of videos of people singing crazy songs and telling funny stories using the letters in the formula. But one way or another, you do need to have it memorized. It will not be on your quizzes. It will not be on your test. Okay, so all you really need to know is that each of the coefficients, A, B, and C, get plugged into their respective places in the formula. We have 2 locations for B, 2 locations for A, and 1 location for C. Negative B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. So let's use the quadratic formula on this equation. So our equation has an A of positive 2, a B of negative 1, and a C of negative 3. So we just plug these into the quadratic formula, work it out using order of operations, and then we'll have our answers to the quadratic equation. So our negative 1, when it gets plugged in, brings its negative, but it's still negative b, plus or minus the square root of b squared, so that's negative 1 squared, minus 4 times A is 2, C is negative 3, all divided by 2 times A, which is 2. Now this looks like a lot to do, but honestly it's just little bits and pieces of order of operations. So let's rewrite what we know. This negative and negative makes this a positive 1, plus or minus. Inside 1 squared is just positive 1, and a negative 4 times a positive 2 is a negative 8. Negative 8 times negative 3 is positive 24. And on the bottom, 2 times 2 is 4. I end up with 1 plus or minus the square root of 25 divided by 4. The square root of 25 is 5, so now I have 1 plus or minus 5 divided by 4. And now it's time to do this as 2 problems. Our first problem is x is equal to 1 plus 5 divided by 4. And our other problem is x minus 5 divided by 4. Our first x plus 5 is 6 divided by 4 would be 6 over 4, which is the same thing as 3 halves. So there's one answer. And our other answer is 1 minus 5 is negative 4 divided by 4, which is negative 1. So 2 answers, much as like our other problems that we've done, and we expect to usually get 2 answers, a 3 over 2 and a negative 1. Our second example, I noticed as I'm looking through my A, my B, my C, there is something that all 3 of these things have in common. They all are divisible by 2. So instead of starting with A, B, and C and plugging them straight into our quadratic formula, why don't we reduce the whole thing by dividing all pieces by 2. This is the same thing as factoring out a GCF. So now I end up with x squared plus 6x plus 9 equals 0. I'm going to take that A, B, and C, A, 1, B, 6, C, 3, and use that in the quadratic formula. A, B, and C plugged in correctly into the quadratic formula would give me negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 9. all divided by 2 times 1. Start to simplify this, and I end up with negative 6 plus or minus the square root of 36 minus 36. 4 times 9 is 36. All divided by 2. 2 times 1 is 2. So when I do 36 minus 36, I end up with the square root of 0. Since the square root of 0 is nothing, this problem has nothing here to add and subtract with the negative 6. So my problem just ends up going to just negative 6 divided by 2. So my final answer for x is x equal to negative 3. This problem only has one answer. Whenever you end up with a 0 underneath the square root sign, your solution is only going to be one solution instead of two. In our last example of 3x squared minus 4x minus 3, our a is 3, our b is negative 4, and our c is equal to negative 3. Let's plug in these coefficients into the quadratic formula. Negative b, again this time a negative follows with the 4, so I have negative 4 plus or minus the square root of negative 4 squared minus 4 times a is 3 and c is negative 3. All divided by 2a, 2 times 3. Let's simplify. A negative and a negative make a positive 4 plus or minus the square root of negative 4 squared is positive 16. Negative 4 times 3 is negative 12, and negative 12 times negative 3 is a positive 36. All divided by 2 times 3 is 6. X will now be equal to 4 plus or minus the square root of 52 divided by 6. In this problem, we end up with a square root that is not a whole number when we square root, but that's okay. We're just going to go ahead and approximate this. So I'm going to do this kind of as a combo. And you're not going to be able to see it on the screen because I'm using my calculator to do this. But I am going to try to figure it out by using a calculator, which is the square root of 52. It comes out to 7.211102551. Anyways, try that in your calculator and see. And notice that this is irrational and the decimals are going to continue on forever. So because of this, I want to get the best approximation. I am going to write down 7.211, but when I type into my calculator, I'm going to type it kind of in all as one go. And the other problem we need to do is 4 minus 7.211 divided by 6. So my calculator, I type in 4 plus the square root of 52 equals divided by 6. And I end up with positive 1.86, but rounds up to 7. And for my second one, 4 minus the square root of 52 equals divided by 6. And I end up with a negative 0.535, so 5.4. So here are my two answers, my two solutions. And yes, it's okay going to decimals and rounding them off because it will help us in a future learning target. So that pretty much covers it. Well, I showed you an example where we plug in A, B, and C. We come out with two nice, perfect, normal numbers, whole numbers. I also showed you an example where you plug in A, B, and C. It comes out with just one answer. But I also showed you an example where we have a square root of a number that doesn't come out whole, but that's okay. We'll just use decimals and round off.